missed in the previous two classes. Okay.
Okay, sir.
So we have discussed the electrolytic reduction. The electrolytic reduction we have discussed. Or should I teach you something? What electrolytic refining should I teach you? No?
Yes,
Tell
sir.
me. Yes. Okay. Have you got your marks in exams?
Sir, half yearly?
Mm,
Yes, sir. My half yearly were conducted before vacation itself. I already have the marks.
okay. Recently you don't have any exams.
No, sir.
So let's discuss this one. Today we will going to discuss electrolytic refining. Now what we have done in the previous classes, let me explain you one more time. That by using various methods, okay, by using various methods such as first of all we during the extraction of metals, we does several steps. Okay, there are the four types of ores. One is the oxide ore. The second one is carbonate ore. The third one uh, is the sulfide ore, and the fourth one is halide ore. Out of these ores, oxide ore is already in oxide form, and these carbonate ore after enrichment, means after removal of gangue from these two, by calcination and roasting, by calcination and sulfide ore roasting. Okay, we do two steps. That is that we convert it into oxide form. Means these carbonate and sulfide ores are converted into oxide ore or oxide form, and this one also in the oxide form. And the halide ore, we will discuss this later. And these three are now become in the oxide form. Oxide ore is already in oxide form. Carbonate ore after calcination got converted into oxide form, and sulfide ore also after oxidation get converted into oxide form. And we were studying the reduction methods. Okay, this was the, I'm just revising it one more time. Potassium, sodium, calcium, magnesium, aluminium, then chromium and manganese here, then carbon here, and then after carbon we have zinc, iron, tin, zinc, iron, tin, lead. Then we have hydrogen. After hydrogen we have copper, silver, mercury, silver, gold. Okay, so when we are having these metals almost in their oxide form, because the oxide ore is already in oxide form, and if we have calcium carbonate, CaCO3, if we have zinc sulfide, if we have PbS, if we have HGS, if we have Cu2s, if we have Fe2s or Fe2O3. So we just converted this by roasting, by calcination, this one by roasting, this one by roasting. So by roasting and calcination, we convert this into their oxide form. ZNS get converted into ZNO, PbS get converted into PbO, HGS get converted into HGO, Cu2s get converted into Cu2O, Fe2s get converted into Fe2O3. Okay, and this is already in Fe2O3 form. So we, by using different methods like roasting and calcination, we just converted their respective ores into their oxide forms. Now from their oxide form, it is easier to extract out metal. Now we can easily extract out metal from their oxide form rather than their sulfide and carbonate form. If the metal is in CaCO3 form, and in case if the metal is in CaO form, then it is easier to extract out metal. It is easier to extract out metal from calcium oxide than this calcium carbonate. It is easier to extract out metal from zinc oxide than zinc sulfide. Okay, everybody understood? Understood?
Yes, sir.
Now we done different steps. Okay, we did different steps. Like by simple roasting, this is potassium, sodium, calcium, magnesium. Okay, aluminium, then chromium and manganese. Okay, then we have iron, sorry, carbon. Again, I'm just going to write it: carbon, zinc, iron, tin, lead, then hydrogen, then copper, then copper, then mercury, then silver. Okay, so if we have these ores was reduced, means if we have Cu2s, then by simple roasting in the presence of oxygen, it first get converted into Cu2O plus SO2, and this Cu2O again react with its crushed ore Cu2s. Okay, and then it gives you Cu plus SO2. So we are just simply heating this ore in the presence of oxygen, and we are just getting, means if you have Cu2s, if you have HES plus O2, it will gives you HGO plus SO2, and further you heat HGO, then it will gives you Hg plus O2. So we are just by simple heating, we can get the metal from copper oxide. Okay, by simple heating or by simple roasting, or by simple roasting, we can get the metal from these. Okay, similarly, if we have this carbon, zinc, tin, okay, so we can extract the metal from carbon, zinc, iron, tin, okay, from these by using carbon, because carbon is above this one. So up to here and up to lead. I'm just going to write lead here. This we have discussed in the previous class also. So if I'm writing lead here, so this can be reduced by carbon, and reduction with carbon is called smelting. Smelting by carbon, and this by aluminothermy, by the help of aluminium. Okay, by aluminium, and this one is potassium, sodium, calcium. These were above, and this we can reduce by electrolytic reduction. Okay, electrolytic reduction. So this by electrolytic reduction. So we have done different method regarding to this one. Okay, and this we have discussed in the previous class, that these ores from their oxides can be separated with the help of by simple heating. These need a reagent, that is carbon. For this one is aluminium. For example, if we have Al2, if we have chromium oxide Cr2O3, and if we react it with aluminium, it will give you Al2O3 plus chromium in liquid state. Similarly, if you have manganese oxide MnO2, it react with aluminium, it will give you Al2O3 plus aluminium, plus manganese in the liquid state. And sometimes we also use this reaction in Fe2O3 and react with aluminium. It will gives you Al2O3 plus Fe in the liquid state. And this is important reaction. This is called thermite reaction. Thermite reaction. Okay. So electrolytic reduction we have done this one in the previous class. So let's move further. And the next one, let's start. After extracting the metals, we have by different methods, we have extracted the metals. By using different methods, we have extracted the metals from their ores. Like for example, if we have calcium carbonate, first we convert it into calcium oxide, and then by electrolytic reduction, because this is on the top series, by electrolytic reduction method, we just convert calcium, we get the calcium, okay, plus O2. Similarly, if we have ZNS, first we do the roasting. Here it is calcination. First we do the roasting, and after roasting, okay, then it get converted into ZNO. And by using carbon, by smelting, we get Zn, okay, or reduction with carbon, okay. So these are the method that by first we convert into oxide form by either by calcination roasting, and then by using suitable methods, either by carbon, by aluminium, by electrolytic reduction, we are able to separate. For example, if you have NaCl, so NaCl is a strong ionic compound that is going to have very high force of attraction. So there is no roasting and calcination is done because it is neither a carbonate or not a sulfide ore. So we generally do the electrolytic reduction. Electrolytic reduction. And in the liquid state, they should be in liquid state. Then it will gives you Na plus Cl2. So when we have a molten, we have molten this one, and we pass electricity to it, we get Na. So this is the several method that by which we can get the pure metal, okay, from the oxide and carbonate form. But still there might be some impurities. The metal that we obtain, it must have some impurities. And for that we use refining methods. Okay, we need to refine the metal. So refining. So only we have electrolytic. There are different methods of refining metals, but only we use here is electrolytic refining. Okay, or we can say that that in our syllabus is only electrolytic refining. Okay, electrolytic refining. You understood? Everybody getting this one?
Yes, sir.
Yes, sir.
Okay. So now what is electrolytic refining? We are just going to use the metal for refining purpose. Okay. So if we are having this, like for example, if we are having this one. Okay. We just made an electrolytic cell like this. And we just connect it with a battery. Okay, and we just take this one with a thin. Let me make this one. During electrolytic refining, there is a thin rod is taken, a very thin rod. Okay, and in the other state, what we have is we have the rod of the metal that we need to purify. This is an impure one. Okay, so what happened actually in the electrolytic refining? For example, if we are going to purify the copper, okay, copper. So what we take a pure copper metal rod. Okay, pure copper metal rod, and it should be at anode. Means they should be at anode. Okay, sorry, at cathode. This should be at cathode. At cathode. Cathode is negatively charged. So we always take the positively charged, negatively charged as pure metal, and we made it. We just take it pure metal rod of copper. Okay, that we break. And this one is the impure that we need to purify. So this one is impure copper metal rod. Okay, and it is connected with anode, at anode. Okay, so what we are doing, we just take a thin rod of same metal that we are purifying. We just made it as cathode. The pure metal rod is taken as cathode, or we made it cathode. Okay, you understood? Everybody getting this one? And the impure,
sir.
the metal that we are going to purify, we just take it at anode. Okay. And for example, if we are just going to purify the copper by this method, so we need to take the electrolyte of that copper also. Okay, so we just take the electrolyte as copper sulfate. Okay, the same metal electrolyte is taken. If you are having, if you are purifying copper, then you will take the salt of copper. So electrolyte of copper should be taken, like copper sulfate is taken. Okay. Now, as you know, you are very much familiar that we must have, when this is in aqueous form, copper sulfate is in aqueous form, so it will have Cu2 positive and it get dissociated and SO4 minus 2 ion. Cu2 positive and SO4 minus 2. Cu2 positive and SO4 minus 2. This will be like this. Okay, got it? So it must have copper positive ion and sulfate negative ion. Got it? So when high electricity is passed through it, and why it is having copper? Because we added copper sulfate as an electrolyte. We have added copper sulfate. This is copper sulfate as electrolyte. Okay, then what is going to happen? At cathode, what would happen? Cathode is electron donating in nature. So you know this is copper 2 positive ion. Okay, it will move towards toward this rod, the negatively charged rod. What it will get? It will get 2 electron here. The Cu2 positive, when get 2 electron, it will get converted into copper solid. And this will deposit here. This will get deposited here. Okay. This will get deposited here. Here it will get deposited. So this copper ion, which is blue in color, when they get 2 electron, become copper solid, which is brown in color. Okay. So slowly, the copper ion from this electrolyte, okay, will start getting electron, will start reducing, and by gaining electron, okay, and simply it get converted into, tell me, into copper atom, and then copper atom or copper solid, and then the slowly this rod will start becoming thicker. Okay, got it? Got it?
Yes, sir.
Yes.
And this start now. What about this one? So as you know that this is going to have copper atoms. This is going to have copper atom in it. This is going to have copper atom, Cu2 positive. Sorry, copper atom, not copper ions. It is going to have copper. This is anode, and it is going to have copper atoms. And along with it is also going to have some impurities like of gold, platinum, silver. Okay. So it is also going to have some impurities like it is going to have Au, Ag, but most of them are copper atoms. Okay. So what is going to happen if the all Cu2 positive ions are moving to this one? So this sulfate ion is actually stable ion, so it will not going at anode. It will remain in the solution. So what would happen if all the copper positively charged ions start going there? And it is start going there. So the concentration of SO4 will increases in the solution. If there is no copper ion, slowly, if the copper ion start going there, then what would happen? What would happen? Then simply we can say that the concentration of sulfate ion will increases. Got it? You understood?
Yes, sir.
The concentration of sulfate ion will increases. And if the concentration of sulfate ion is increasing, getting, if the concentration of sulfate ion increasing, the solution will become negatively charged, and it never happens. A solution cannot become a negatively charged. So to balance that negative charge, the atoms that are present in this rod, in this impure rod, only the copper atoms will start losing electrons. Okay. Okay. As you know that we have a reactivity series. And this reactivity series is based on the principle that which the element that can easily lose electron will be considered as the top. So if I'm talking potassium, sodium, calcium, magnesium, so the element potassium will lose the electron at the highest level, okay, in these. So it is most reactive. Then after potassium, the sodium can release 1 electron. Then calcium, then magnesium. So slowly we move downward. Here we have copper. If we have gold, okay, Ag, then gold and platinum. So if we are having silver, gold, platinum in this rod, so and if there is asked that which one can easily lose electrons, so you know that copper come in the above, or we can say that copper comes above in the reactivity series. So if this is gold, platinum, other pure metals impurities are present in this one, okay, like copper, gold, so they are not going to lose their electron. Only copper will lose its electron because it is more reactive. Okay, so the copper ion from this one, it will easily lose its electron. So what would happen at cathode, sorry, at anode? What is going to happen? The Cu solid atom will loses 2 electron and will become copper ion. And what would happen if our atoms loses electron and become copper ion, and then it will comes into the solution. So from this solution, the metals are going on this rod, or it is getting copper solid to get converting into copper solid. Okay, and the equal amount of copper atoms are converted into ions. So what is actually happening here is that you can understand that if 1 atom of copper ion Cu2 from this solution, from the copper sulfate solution, is converting into the copper atom and depositing on this rod, the equal amount of copper atoms are get converting into copper ions. So from this, it comes to this one, and then it goes to this one. Okay, so this process remain continued. Got it? Got it?
Yes, sir.
Understood, everybody? That let me explain you that what is going to happen here. Let me explain you one more time that this is a rod, thin pure metal rod. And why we are making this one pure? Because if we should have, because every atom is going to deposit over this one. So if we have impure inside, then how we can consider this one as pure metal or pure metal resistive? So inside it must be pure. Then over it, if the atoms are depositing, they are also pure. So the whole rod will be pure. If we have impure inside, then the metal, the ions will start depositing here, and we will have impure inside and then pure outside. So this is not so. So we take the pure copper metal rod, copper metal rod, and we have copper ions. What we have? We have copper ions. Cu2 positive ions are blue in color. And because of that, copper solution is blue in color. Okay. And we have sulfate ion, SO4 minus 2, SO4 minus 2, Cu2 positive, Cu2 positive, SO4 minus 2, SO4 minus 2. So what is when electricity is passed? When electricity is passed, okay, this is impure. When electricity is passed, the copper ion will start going there. And since cathode, the negatively charged rod is actually, we can say that it is electron donating in nature. So Cu2 positive ion will get 2 electrons, and when they get 2 electrons, it will get converted into copper solid, which is brown in color. So it will start depositing on this one. Slowly, copper ions from this solution will get 2 electrons and then form copper solid, and it will start depositing here. Okay. And in order to balance the charge, because if all the copper ion start going there, then CO4 minus 2 concentration will increases. And if CO4 minus 2 concentration increases, then what would happen? What would happen, dear students? Then the solution will become negatively charged. It is not possible. So in order to prevent the electrical, we can say that in order to maintain the electrical neutrality of the solution, this sulfate ion is stable. So it is not going to going here. It will remain in the solution. So in order to balance the electrical neutrality, this copper atom that are present in this one, along with some impurities like Ag, Au, this copper atoms will loses its electron and will get converted into Cu positive ion, Cu2 positive ion. So it will get converted into Cu2 positive. So if one atom from this solution is going on this one, then the one atom from this one is coming into the solution. Okay, so if one ion of copper sulfate solution is converting into copper solid, then the same amount of copper solid from anode is get converting into Cu2 positive 2 electrons. So this is the way that how the electrical neutrality is maintained. Slowly, we will find that this rod will disintegrate. This will become thinner and thinner and thinner and thinner. And this will become, after depositing, this will become thick. So at the end, what we will get? At the end, we will get that this rod become very thick. Okay. Slowly, this will become thick. And this rod disintegrate. Okay, this rod will disintegrate, or it will get consumed. And at the end, we will take that there's some impurities at the bottom of this one. We will have some impurities at the bottom, and this is called anode. We'll call it anode mud. So is there anyone in the class who did not understood the electrolytic defining method? Yobita, Tejasvi, Abir, you understood? Shoaib?
Yes, sir. Understood.
Yes, sir.
Shweta, you understood? Shweta, are you there? So please, dear student, please note it down.
Yes, sir.
Okay.
Yes, sir. I'm there. Sir.
Okay. So here's a question that write a note on electrolytic refining of copper. Please note it. First draw this one. If you have not drawn this chart, please draw this chart. This is before and this is after. Please draw this chart.
Done, sir.
Is there anyone? Okay.
Done, sir.
Okay, please note it down. Note this. Please note this one.
Noted, sir.
Noted. Okay. Everyone, is there anyone who's still writing?
Sir, I'm writing.
Okay, okay. Write it. Done?
Yes, sir. Done.
Note this one also. Done? Dear student, please make this chart, okay? Write the notes, write the name of these ores that are important. The bauxite ore, okay? Copper pyrite ores, so this is Cu, Fe2S, copper iron pyrite, zinc blend, ZnS, okay? So these are the ores. This is an ore for aluminum, this is an ore for copper, this is for zinc, magnesium, okay? So sometimes they have names maybe asked in the examination in objective, like Glena or lead glens. This is also called lead glens or Gelena. Okay. So this is an ore for what is the magnetite is an ore for, cinnabar is an ore for. Okay. So this may be asked in the examination. So the most important is this one, 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 and this one. And this one also. These are most important. Magnetite may also be asked. Please make this.
Done, sir.
So
Is
can you
there
show me the previous slide?
previous slide? Wait a minute. Which one? This one.
Yes, sir.
Is there anyone who's writing the names of the ores?
So I was right.
Wait a minute. When you're done, Shweta, let me know, okay?
So this is anode, called anode.
Anode mud.
Okay, sir. Thank you, done, sir.
Done. So please note this one. When you're done, please let me know, okay?
Sir, can I rejoin? Your screen is not visible to me.
Actually, I have just paused that one. Wait a minute. Is it visible to you now?
Yes, sir.
Noted, everybody? Should I move forward?
Yes, sir. Yes, sir.
Okay. So just a minute. So now the next topic is alloys. Alloys are the homogeneous mixtures of two or more metal or non-metal metals. Okay. Okay. So if I'm having this one, so it is alloys. If I talk about this one, that what are alloys? Okay, the alloys are the homogeneous mixtures when two or more metals or non-metals, okay, they are physically combined together. We call them alloys. So what are alloys? Alloys are the homogeneous mixtures. Homogeneous mixtures of two or more metals, metals of two or more metals or metal and non-metal on non-metals. And why? What is the basic principle of metal? Why we are making alloys? Okay, the reason behind this is what is that there are certain other purposes that are important, or that's because of that we are making alloys. The first of them is that to increase their tensile strength. Okay, the purpose of making alloys, purpose of making alloys. Okay, maybe first one is to increase durability and tensile strength. Okay, the second one, to increase or decrease melting and boiling points. Okay, to increase or decrease conductivity, to increase or decrease conductivity. So there are so many purposes to prevent from rusting, So there are so many purposes for making alloys. Okay, how can we increase the durability or tensile strength? For example, as you know that iron atoms, we will go back to the slides. Just first, let me explain you. For example, this is the iron atom. So when these atoms are combined together, they form like this. They are placed in layers. They don't think that the atoms in the metals or the element, they are arranged in any order. They are not like this. They have fixed shape, or we can say that they have proper arrangements of atoms. They are not present anywhere. They are not present like in jumbled form. They have a proper order. Okay, so if I'm talking about this one is iron atom, this is another iron atom, this is another iron atom. Okay, so one layer is placed over the another layer like this way. Fe, Fe. Okay. So when the force is applied, then this layer, this first layer, can slide over the second layer. Like how it can slide? Like we have these atoms, okay, and then after sliding, it can reach to this place. I mean, this can slide to this place, and it can come in between this one. Means the atom can slide like this way. Instead of first layer can be like this. This can come here. This can come here, and it can be like this. So there is a, when the atom slides, it means there is a distortion. Distortion means the shape of the metals can be distorted. Okay, so it can reduce the tensile strength. It may change the shape of the okay. So what we does in this one, we have some, when we are having iron and we melt it, and we on melting we add 1% carbon to it, 1 to 1.5% carbon to it. Okay, on adding carbon, the carbon atoms are smaller in size as comparison to that of iron atoms. So the carbon atoms actually goes into this space here. This is the carbon atom that it goes here. And when carbon atoms come into the void, these are called voids. What we call this? These are called voids, the space, voids, vacant space between the two layers of atoms. Okay. So the atoms goes into this space, and this prevent the distortion. Now this the layer cannot slide because there is already space filled with the atoms. Okay. So this happens. The atoms of carbon can comes in the space between them. As a result of which, this tensile strength of iron becomes strong. Means the iron becomes more stronger, and it does not distort. Okay, shape will remain same. It becomes undistorted. Okay, as a result of which, tensile strength increases, its durability increases. Okay, so this we called it steel, not stainless steel. We're just talking about steel. Okay, this is called steel. When we add chromium, nickel, no, chromium, metal, nickel to this one, then it become stainless steel. Okay, so if we are having only carbon, so railway tracks are made up because railway tracks, you know that a huge load is passed over these railway tracks. So actually, what we does here is, in these railway tracks, we just use this type of steel, which is mixed with carbon, 1% carbons. So these tracks does not distort their shape, even if a heavy train passes over it. Okay, so okay, this one. Similarly, if we know that they are the two atoms of an element, they are the two atoms of an element, and there is a force of attraction. For example, if I'm having this AA atoms, okay, and there is another element that is BB atoms. This is B element, and this is going to have BB atoms. And we know that if we know that there is a force of attraction between A and A, there is a force of attraction between AA, and there is also a force of attraction between BB. Okay, but the atoms of A and B do not like each other. They don't like each other. So if we mix the atoms of A and the element A with element B, so they will arrange themselves like this. Okay, it can have B, A for sometimes continuously, but if it will arrange like this: A, B, A, then B, okay, then A, then B, and as a result of which, they are not attracting themselves. A is repelling, so A will repel B, and B will repel A. Because of that, because they don't like each other, their properties, these atoms do not like each other. There is a force of attraction. Let's suppose there is a force of attraction between X, and there is also a force of attraction with Y. So when you mix them, actually they are repelling. So the force of attraction is not X plus Y. It is less than X plus Y. As a result of which, the alloy made by mixing A and B will have low melting point. So we have solder. Okay, solder. This solder is a paste that is, or we can say that is an alloy which is made up of lead, Pb, and tin. Lead and tin. So when we mix lead and tin, we got the solder, which is used for, which can easily melt. It has very low melting point, and it is a good conductor of electricity, and it has very low melting point, and we can simply say that it is used for soldering purpose in the electronic appliances. Okay, so this we can say here that this Pb and Sn, Okay, Pb and Sn, they don't like each other, so when we mix them, these are going to have alloy which is going to have low melting point. Everybody understood? Everybody understood?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And sometimes we have bronze. Bronze is made up of copper and tin. Okay, copper and tin. Actually, copper is provide the tensile strength and tin also, and they like each other. They like each other, but tin is lighter in weight as comparison to that of copper. So when we have bronze, so we will have first of all, copper atoms have force of attraction between copper atom. Okay, this is copper atom, and this is tin atom. Okay, I'm just going to have tin Sn is tin atoms. So this is the force of attraction let the between copper is X and between this copper is Y. So they like each other. They like each other. Copper and tin like each other. They don't repel each other. So they will attract, copper will attract the tin. Then okay, with more force. So here the force between these two will not be X plus Y. It will be greater than X plus Y. And so it will be, we can say the bronze is more powerful than, or we can say it will have more strength than this one. Okay, so we can have an element which is lighter in weight, and because tin is lighter as comparison to this copper, and moreover we will have we can have X, because force of attraction is greater than X and Y, X plus Y. So we will have it means their durability will increase here in bronze. Okay, because there is a more force of attraction between this and this. So durability will increase and the lighter in weight. So this is used for making ancient times weapons like sword, okay, shield, okay, or we can say if there are different weapons that were used in the ancient war. So these were made from bronze. Okay. Similarly, if we need to make the aircraft is made with duraluminum or magnesium. So there are the different types of alloy. Depending on the type that what kind of metals or what we want actually. If we want low melting point, then we mix those that don't like each other. If we need a high melting point or boiling point, then we mix those elements that are going to have more force of attraction between them. And if we want to increase the durability, like in steels, we just put the carbon atom, which is smaller in size, to prevent it from durability. Okay. To prevent it from distortion, so we just put the carbon atoms in place of. So this happens like this way, and here certain matters. So this is the table that I have made here. So you don't need to write each and every one, just write the important one, that brass, the constituent of brass, bronze, and then duraluminum, that is used for making utensils, magnesium, it is used for making aircraft. Okay, and stainless steel. Okay, so please note the constituent of these brass, bronze, duraluminum, magnesium, that it aluminium and manganese, magnesium, aluminium, copper, magnesium, and manganese, duraluminum.
Sir, can you scroll down?
Yes. Right, solder also, solder.
Noted, sir.
Noted, everybody? Okay. Okay, so right, one more thing that if I'm talking about ferrous alloys, so what are ferrous alloys? Ferrous alloys are those alloys in which one of the constituent is iron. Okay, so ferrous alloys means those alloys in which one of the constituent is iron. For example, stainless steel, normal steel. Okay, one of the constituent should be iron. Okay, should be iron. And amalgam, those alloys in which one of the constituent is mercury. Okay, so if there is mercury in any one of the alloy, then we called it amalgam. Okay, like for example, sodium amalgam, potassium amalgam. Okay, so this is amalgam, means one of the constituent is mercury. Okay, you understood? Everybody in the class understood? Okay. So one more thing you need to understand here is that dear students, we have finished this chapter. In the next class, we will going to start the carbonate compound chapter. That is very important. So everyone have to present. No student is will be allowed to take a single leave. Okay. This is very important that every student should take the class, because this is the first chapter of organic chemistry. If you are going to take the science stream in the next 11th standard, then it is must that everyone should learn this chapter, because this is the basic of chemistry. Okay, organic chemistry. So everyone has to understood the concept of carbonate compound. And moreover, dear students, you need to keep in mind here that we are going to give you the homework, because we have just completed this chapter, and there will be test of in the next class, most probably, that will be the alloys, metallurgy and salts. Okay, only salt portion in chemistry and metallurgy. Okay, most probably.
Yes, sir.
Got it. So that's all for today. We'll meet you in the next class.